So we're looking at chapter 5, which is risk and return. So risk and return is a topic that assumes that investors have a behavior in investment such that the risk attached to the investment is inversely related to the return. So like the Phillips curve, the relationship that exists between return looks like this. So the higher the risk, the higher the expected return. So we need to understand that investors could be risk averse, they could be risk seekers, or perhaps they could be indifferent to risk. So if it's a risk seeker, they'll follow risk. So meaning where there's higher risk, they will seek to invest with the assumption that the higher the risk, the more the return. If the risk averse, these ones will follow as at all costs, they will avoid risks. So they only want to associate themselves with less risky portfolios. So this is how the pattern is with the different types of investors. So the expected return is simply given by the summation of the probabilities times the returns. That is how it goes. Expected return is simply given by it's simply given by the return times the associated probability. So now we're going to look at the different types of investments that we have respective to different business cycles. So we have business cycles that undergo these, have a boom, which exists at a peak. Then when the economy is contracting, it goes into a recession. If it exceeds more than a year, it's called a depression. And when it survives this phase, it will start recovering and going into the recovery phase, causing the economy to expand and entering what is called an expansionary phase. Then we go back to the what? To the peak. So the states of nature are simply the seasons within which an investment will survive. Now, you must also understand that risk is quantifiable. The relationship that risk has with its return is measured by what is called beta. Beta. So the higher the beta, the higher the risk that is involved. So investors are deemed to be rational beings, always wanting a higher return for a small investment. So the term return or expected return is actually used interchangeably with mean or average, which is simply the value or the mean value of the associated probability of the possible events. So when we weight that, we get what we call our expected return. So risk, by definition, is simply the chances that the actual returns that we intend to have deviate from our intended or expected. So it's simply the exposure that we have to a loss. That is what we call risk. So we're going to hover around these terms: risk, which will be measured in terms of the standard deviation and the variance. Return, we're going to be looking at the expected mean value, the expected return. Then the percentage of the deviation between the standard deviation and the return is what we're going to call the coefficient of variation, CV, which is simply given by standard deviation over the expected return times 100. So a higher CV simply implies that we have a higher risk. So given two portfolios, what would you pick? It depends. I ask you, you need to describe it as follows, okay? Depending on the type of investor. If it's a risk averse, they will avoid risks at all costs. It's a risk seeker, they'll be attracted to risks at all costs. So you need to really understand what I was talking about. So far, we're together?
Yes.
All right, so I'm trying to take my time so that you can appreciate the concepts. This is one of the most survivable topics. Now I'm going to look at 4 key parameters: portfolio, expected returns, portfolio variance, portfolio standard deviation. So I'll look at 2 assets, asset A and asset B. So we have probabilities 0.5, we have probabilities 0.3, we have probabilities 0.2. The total probability must add up to 1. So maybe the states of nature, we can have a normal, a boom, and a recession. So here we have maybe 500, or 100 kwacha in a normal for asset A, a 200 kwacha in a normal for asset B. And here we're given 500 for asset A versus, then here we're given a 400 for asset B, and here we're given negative 200 for asset A, negative 150 for asset B. So we want to calculate 4 things. Number 1, the expected returns for each. Number 2, the standard deviation for each. Number 3, the coefficient of variation. That's number 4. Then we'll also be asked the portfolio expected return. Supposing that there's a 50% investment in each, that is our portfolio standard deviation. Then maybe the covariance as well, and the correlation as well. So all these will be asked, and maybe the portfolio standard deviation. This is a very stuffed question. So we'll start with asset A. So the way I'll do asset A is the way I want you to do asset B. So how do we find the parameters that have been asked? Okay, let me do this. Maybe I can do all of them together. So we have probabilities, 0.5, 0.3, and 0. What? 2. Then we're given as return on asset A. What did we have? 100, 500, and negative 200. And negative 200. So the expected return is simply when we multiply the probabilities times the returns. So probability times the return on A. So here we're going to have what? 50. Here we're going to have what? 150. Here we're going to have what? Negative 40. So let's sum up what are we getting? Expected return
160.
on A is 160. Okay, those who were here during lunch, what follows next? We subtract the returns minus expected returns. Okay. So 100 minus 160, we get negative 60. And we square it and multiply by what? The probability. So what is 60 squared times the probability? What are we getting? I left my calculator so you do well to assist so that we move quickly. So 60 times 60 times 0.5. So here we have 1800. I'll start with the first one. Okay, the gents can continue with this one, and the ladies the last one. So what do we have here?
Sorry, Mr. Collins. So we ignore the negative. I found negative 1800.
The negative comes out when you square it.
Oh,
If you don't put it in the brackets, it will be negative. So calculator is in BODMAS.
all right, thanks.
Okay, 500 minus 160 is 340. Then what do we do? We square 340 and multiply times 0.3. What do we have? 34.
680.
680. And here what do we have? Negative 200, negative 160. What do we have? Negative 360. So what do we do when we square that? And we multiply by 0.2. And 5, 920. All right. Then when we add everything up, we get 62,400. That's a variance. 62,400. And when we square root this, what are we getting? Square root 62,400, what do we have? Quickly,
Is it 62,400?
help me. I don't have a calculator.
Yes, it's 62,400, and then the square root is 249.79.
Pardon?
249.79,
Mm-hmm.
or
0.7.
maybe we just say 0.80, I don't know. 799.
Also 780, yeah.
Yeah.
So how do you find the coefficient of variation? Standard deviation over what? Expected return. What do we have? One point what?
1.56.
1.56. Okay. 1.56.
Mm.
So we go to returns on asset B. 200, 400, 150. The same probabilities are the ones that we're using. If you want, you can bring them back here. 0.5, 0.3, 0.2. Quickly, let's find the expected return. What do we do?
We multiply.
Multiply, correct? So what are we getting here?
100.
100.
120. 30.
Negative 30, yes.
Mm.
When you total up, expected return for asset A, or asset B this time. What do you have?
190.
190. Next, what do we do?
We subtract 200 minus 190.
So what do we have here?
That's 10.
10, then square it.
Then that's 100
And
times
0.5.
0.5. That's 50.
Yeah.
And 400 minus, that's 210. Then 210 we square it, then we multiply by 0.3.
Which is
13 to 30.
13 to 30.
Then negative 150 minus 190, which is negative 340. We square that. Then we multiply by 0.2, 23, 120. Yeah, and then we sum up that.
We call it the variance when you sum up. When we square root it, it's a standard deviation. When we divide by the expected return, we call it the CV for B. Let's calculate in that order.
So it's 36,400, which is variance.
So this is what?
36,400.
36,400. And square root it.
190.79.
190.79. We divide it by the expected return, what we have. 1.0.
1.00.
So which one has more risk between the two of them?
It's A.
A has a higher risk. The higher the CV, the higher the risk. So which one is riskier? A. And how do we find the covariance? We go now to calculating these three important columns. Multiply these columns. That's expected return. So A times the expected return for B. So here we have 0.5, 0.3, 0.2. Then return this column here. See, these are key columns. You need to take note of them. So this column, and this column. These are the ones that are needed. So here we have what? Negative 60. And there we have 340. Then we have negative 360. Then here we have 10 to 10, negative 340. Then we multiply these three together and sum up for the variance. So what are we getting here? 0.5 times this times that. What are we getting here? Negative 300. Is it?
Yes, yes.
And here what are we getting?
21,420.
21,420. And here,
24,480.
448. And you sum up, this is called the covariance of what? A and B. What is the total?
$45,600.
5,600. Is there anyone lost behind so far? Am I a little bit fast? Have we left anyone behind? Ambela? Are we together?
Yes, I'm following.
Francis, are we together?
Yes.
Right. Then we have what we call the correlation. Correlation is simply given by standard deviation for asset A, standard deviation for asset B over the covariance of A, B. So covariance gives you direction in which your assets are moving. If you get a negative, they're negatively related. So this is standard deviation for asset A. So 249.8. Asset B, 190.79 over correlation, which is what? 45,600. What are we getting? Coefficient of correlation. What are we getting?
$1.045.
1.045. Confirmed?
Yes.
Positive 1.045. All right. Now, we can also calculate what we call portfolio expected return. So remember I said each of these ones, investment was done 50-50%. A portfolio is a combination of what? One or two assets. So expected return for the portfolio is simply the weight for asset A times the return for asset A plus a weight for asset B times the return for asset B. So you'll be given the weight. Sometimes they say 60% was invested in asset A, meaning 40 will be in asset B. Okay, so here it is 50-50. So here 50% times the expected return for asset A, 50%, the expected return for asset B was what? 190. So what do you get? What do you get? 175? Is it?
Yes.
So this is what we call the expected return for the portfolio. All right. Then we also have what we call a variance for the portfolio. Variance for the portfolio.
Hi, Collins. Are you able to go back to the screen, the previous screen? I just want to check something.
Yes.
Okay, thanks. That's fine. Thanks.
Together. All right. So how do we calculate the portfolio variance? I'm sure you've seen it somewhere. The long formula. How do we find the portfolio variance? Those who've been studying. So portfolio variance, by the way, measures the dispersion or the variation or the volatility of the returns of a portfolio. It aggregates the actual returns given a period of time. It's calculated using the formula weight of asset A times the variance for asset A plus, so it's given a weight for asset A or asset 1, whatever you're using, multiplied by its variance plus weight for asset B squared times variance plus 2 weight asset A, weight asset B, and the covariance of AB. So what was our weight for asset A? It was 50%, right? What was the variance for asset A? It was 62,400. I'm not squaring this because I'm getting the variance. I was getting the standard deviation, I'd have squared it. Are you following me?
Yes.
So don't ask why I haven't squared there. If I pick this one, 249.8, I would square it to get back to the same thing. And variance for asset B, 36,400. Then plus 0.5 times 0.5. Remember, the 0.5 is coming from the fact that we are told that the investment was 50-50. If it's 30-70, you follow that order. Are we together?
Yes.
Okay. Then you compute after multiplying all these. You compute, what you get is a variance. When you square root it, it's called the standard deviation. All right, so this is as much as they can ask regarding this topic at hand. I've simplified it in the most basic manner. It's a tough.
Sorry, Mr. Collins.
Uh-huh.
Covariance AB, isn't it 45,600?
Covariance AB, you're the one who calculated it. You gave us here.
Isn't the
That,
1.045, isn't it the correlation?
oh, okay. Thank you. What was the covariance? It is 45.
45,600.
600. Excellent. Thank you. You're following. Thank you so much. 45,600. Okay. So That is the thing. Then you square root it to find the standard deviation. Now, sometimes you may be given just the returns for asset A and asset B, and you're not given probabilities here. So the assumption is that we have equal probabilities. If there are 3, you use 1/3 of each. If there are 4, 25% of each. Are we together? So let's go to this exam paper. It's for last year. We are given stocks from 2010 to 2015, and the returns are as follows. What is the return of each stock from 2010 to 2015? What probabilities do we use? What probabilities do we use?
0.2.
100 divided by 5, which is 0.2. Then one person was following. Everything I mentioned was very important. So 0.2, then you do each of these returns, you get your 4 marks.
Sorry, I think I'm a bit behind.
I said if you're not given probabilities, you assume the equal probabilities. So we have period 1, 2, 3, 4, 5. We divide 100% by 5. If there are 4, we divide it by 4. If there are 3, divided by 3. You apportion the probabilities equally. Is that clear?
Yes.
So this will be your homework. I'm just leading you through to see that I've taught everything. All right. Then assuming 50% of stocks were invested in this company and 50% in there, what would be the realized return on the portfolio? So we are looking at the portfolio return. Easier. What is the standard deviation for each stock passing from 2010 to 2015? So if first find this variance and standard deviation. Then which of the stocks performed better, both in terms of the return and the risk? Back your answers with computations. 25 marks. So this is where most students should survive. This is a question you should not really hesitate to pick up or answer. Are we together? Are we together?
Yes.
Yes.
All right. So it is one topic that does not depend on any of the underlying yeah